Good morning, class, and welcome back to 7th grade math. Today we'll be talking about solving inequalities. Previously, we were talking about solving equations. Equations are expressions that are equal to each other. Inequalities are expressions that are not equal to each other, and instead of using an equal sign, we use inequality symbols such as greater than, less than, greater than or equal to, and less than or equal to. So let's do a quick recap on how to solve an equation. So to solve an equation such as x minus 2 equals 5, we just add 2 to both sides. Notice in our example. The question is it the same when we are solving inequalities? In order to answer that question, let's start with an inequality that we know is true. For example, we know that 4 is less than 6. This inequality is true. So what happens if we add the same number to both sides of this inequality? Will it still be true? I'm going to add 3 to 4 and 3 to 6. So I'm adding the same number to both sides to see if the inequality statement is still true. 4 plus 3 is 7, 6 plus 3 is 9, and I haven't changed my symbol. This inequality is also true because 7 is less than 9. So this example shows us that if I complete the same steps that I would normally complete in an equation, that my inequality will still be true. So to solve inequalities, we just solve it as if it's a regular equation, keeping your symbol the same. So let's start off with adding or subtracting to solve inequalities. Notice out to the side that it says our goal is still the same, and that is to get the variable by itself. Remember with our equations, when we tried to get the variable by itself, that meant that I had to cancel out the constant that was with the variable. In this case, m plus 8 is less than or equal to 28. In order to get the variable by itself, I have to cancel out this plus 8. In order to cancel out that plus 8, I have to subtract 8 from that side. Now we know that what I do to one side of an equation, I do to the other side of an equation, and that is also true with an inequality. On my left side, my 8 cancels out, leaving me with m on the left. On the right, 28 minus 8 is 20. So m is greater than or equal to 20. All right, let's practice this one more time with example number 2. I'm actually going to change this to m minus 4. Okay, so m minus 4 is less than negative 6. Now, because we have a negative in here, we need to keep in mind our negative and positive rules. In order to get my variable alone, I have to cancel out minus 4. To cancel out minus 4, I have to do its inverse, or add 4. What I do to the left side, I must also do to the right side. On the left, my 4 cancels out, leaving me with m. Negative 6 plus 4 is negative 2. So m is less than negative 2. So that's pretty easy. Well, let's move on to multiplying or dividing by a positive in order to solve an inequality. Now notice I said by a positive because that will be very important in just a second. Now, just like with an equation, when we're solving an inequality, in order to undo multiplication, we have to divide. In order to undo division, we have to multiply. When we see a constant right next to a variable, that means that it is multiplication. So in this inequality, 6 times x is less than or equal to 18. In order to undo 6 times x, I have to divide by 6. What I do to the left side, I must also do to the right side. On this side, it cancels out my 6, leaving me with 1x. On the right side, 18 divided by 6 is 3. So x is less than or equal to 3. In example number 2, x divided by 5 is greater than 4. X divided by 5 is greater than 4. So in order to undo division, I have to multiply both sides by the number that I am dividing by. In this case, I'm dividing by 5, so I would multiply both sides by 5. On the left, my 5 cancels out, leaving me with x. On the right, 4 times 5 is 20. So x is greater than 20. So still keeping it pretty simple, pretty basic. But now we're going to get into something a little bit more tricky. Multiplying or dividing by a negative in order to solve an inequality. So far, we've been able to solve inequalities in the exact same way we solve an equation and just leave the inequality symbol the same. The tricky part comes when you multiply or divide both sides of an inequality by a negative number. So let's start out with an inequality that we know is true. We know that 4 is less than 6. And here's what it looks like on a number line. Here's 4, and here's 6. We know that smaller numbers go this direction, and larger numbers go this direction. So now let's see what happens when I multiply both sides of my inequality by a negative number. Negative 1 times 4 is negative 4. Negative 1 times 6 is negative 6. Now, if we keep our symbol the same, notice that the statement is no longer true. Because what do we know about negatives? As we get farther into the negatives, the number gets smaller. So negative 4 is actually greater than negative 6. Now this is where we come to our special rule for solving inequalities when multiplying with a negative number. The special rule states, when multiplying or dividing by a negative, flip the sign. So for this example that we just saw, when we multiplied each side by negative 1, we would actually flip the symbol that's in the center to its opposite. And this would make our statement true. Negative 4 is greater than negative 6. So let's look at an example. In this example, we have negative 2x minus 5 is greater than or equal to 1. Now, because this is a multi-step inequality, we have to start with the operation that is closest to our symbol, in this case minus 5, and work in the opposite direction. So instead of undoing multiplication first, I'm going to undo the subtraction first. So in order to undo subtraction, I would add 5 to both sides, which cancels out 5 on the left side, leaving me with negative 2x. And on the right, 1 plus 5 is 6. Now I'm going to undo my multiplication. Negative 2 times x is greater than or equal to 6. In order to undo multiplication, I would divide. On the left side, I cancel out my negative 2, leaving me with x. And on the right side, 6 divided by negative 2 is negative 3. Now remember our special rule. When multiplying or dividing by a negative, we must flip the sign. So now, instead of it being greater than or equal to, my sign is going to be less than or equal to. So the solution to my inequality is x is less than or equal to negative 3. Remember that you do not need to flip the sign if you're adding or subtracting, so don't be tempted to see a negative sign in the problem and assume that you need to switch the sign. You only switch the sign if you have multiplied or divided both sides of the inequality by a negative number. That's all for today, guys. Thank you so much for listening. Go ahead and complete your assignment for today.